Hi, and welcome to this quick recording on how to calculate percent error. We would have already done this in class as well, but I just wanted to make sure it's here on the document since it's the first time we're using this equation. And so calculating percent error is often done in a lab experiment to see how good your data is. How good is the experiment? The closer you have a percent error to zero, the better, right? If you have 100% error, then that's terrible. So anyway, when I'm going to go ahead and do a percent error calculation here on this document, and I'm going to use different numbers. I'm just going to make up some numbers. We'll see how bad it is. So I'm going to say my actual value, and that usually comes from, known values. You can find it on the internet. You can find it in textbooks, right? So I'm going to say that I know that, let's use water. The density of water is 1. So my accepted value is 1 gram per milliliter, right? That's a known value. That's not for my experiment. I looked it up. Your experimental value is going to be what you get from the lab. And in this case, it's going to be our slope. And so let's say my experimental value is 0.8 grams per milliliter. Right? So now I have my two values and I want to calculate my percent error. So again, your actual value, I'm so used to calling it actual. This equation is calling it accepted. It means the same thing. I'll change it so there's no confusion. So accepted value or actual value is what you've looked up somewhere. That's the known value. And the experimental value, of course, comes from your experiment. And in our case, it's going to be our slope. And so now I want to plug it into this equation. So my percent error is going to be equal to, that's an absolute value sign because you don't want to have a negative error. That wouldn't make sense, right? So there is a line on your keyboard you should be able to find there to put in your absolute value line. I'm going to make a quantity here because I'm not going to do the fraction thing to make sure that I have my denominator right, but I'm going to take my experimental value, which is 0.80. I'm going to subtract my accepted value, which is, maybe I should put the units in there too, so you could see that they cancel out. I'm going to subtract my accepted value, which is 1.0 grams per milliliter. And I'm going to divide that by my accepted value, which again is 1.0 grams per milliliter. And I'm going to plug that in my calculator. Notice that when you add or subtract, which we normally don't do in chemistry, it's not typical that we have to add or subtract, but when you do, the units have to be the same. Just like in math class, you can subtract 2x minus 3x. You cannot subtract 2x minus 3y, right? So your variables have to be the same. Your units have to be the same when you're adding and subtracting, and mine are here. So grams per milliliter, grams per milliliter. We also know from our dimensional analysis work that when you divide by the same unit, they cancel out. So I end up with grams per milliliter over grams per milliliter, which cancel, which means my value, my answer has no units. And it's, again, it's a percent error. It shouldn't have units, right? So they should cancel out, which is why I included them in there. All right, let's see. Did I bring my calculator? So I'm going to go ahead and take 0.8 minus 1, and then I'm going to divide that by 1, which again, you don't really have to. And I end up with a negative 0.2, which again, I want to take the absolute value of that. Oh, I forgot to put my absolute value symbol there. So it becomes a positive 0.2. And then I want to multiply that by 100% to change it to a decimal or change it to a percentage. All right, so again, if you plug this into your calculator, you should get 20%. So 0.8 minus 1, hit enter, divided by 1, and then times 100%, or move the decimal point 2 places to the right. And so I end up with a percent error of 20%, which is all right, I guess. Usually 10% or less is pretty good. Actually, when you're doing real precise chemistry labs, you want to have it less than 1. You want to have as smallest error as possible. So the closer you are to 0, the better. If I had to explain this, so my next question down here is use your percent error to explain if the experiment results are good. I would say that this is pretty good, 20% for what we're just doing here. You're going to end up with a percent error smaller than that. So you can say that your percent error was good and explain why, right? So the closer you are to 0, the better it is. And since this is the first time that we're doing this, again, I just wanted to go over this. We'll get another opportunity to do percent error as we move through the rest of this unit and this semester. All right, if you have any questions, just let me know, and good luck with your percent error.